Hello, everyone, and welcome to today's session, Time and PTP Waits for No One, designing and testing multi-tier reference architectures for hybrid SDI IP broadcast facilities. So, Steve Holmes and Kevin Salvidge are here from Leader, and they are joined by Ryan Morris and Gerard Phillips from Arista Networks. And between them, they've all been working hands-on with broadcasters around the world as they migrate from SDI to IP. So if that sounds like you, stay with us, because today we'll unpack some of the biggest challenges broadcasters face when synchronizing SDI and IP systems, explore how multi-tier PTP architectures can be designed and tested effectively, and share some practical lessons from real-world deployments. So, Steve and Kevin, over to you.
Cindy.
Thank you, Cindy.
Thank you once again. And Steve, here we go. Back to one of our favorite subjects.
Yes, good old PTP. Hey,
And
the item that just keeps on giving. What can we say?
it does. And obviously, we're very fortunate to be joined by Gerard Phillips and Ryan from Arista again.
Good to see you. Thanks for having us on. As ever, it's a pleasure. And as ever, as you said already, PTP is the subject that keeps giving, and there's always more to talk about. So let's do it.
Well, let's just start with the big picture, Kevin. Why has the shift from SDI to IP become sort of a matter of when and today, not if, you should do it? It's becoming more and more mainstream.
It certainly is. I mean, broadcasters are realizing that IP gives them scalability and flexibility that the SDI basically simply can't match. You know, with standards like 2110 have now matured. Interoperability has significantly improved. And, you know, IP is enabling resource sharing across production sites, especially, you know, and it's allowing kind of remote and distributed production models. But the question we're frequently asked kind of is, where do I start? And there's a well-known joke for any of you who've ever visited Ireland that a tourist is asking one of the locals for directions in Dublin, to which the local replies, well, sir, if I were you, I wouldn't start from here. And I think that probably sounds familiar for most of our customers. So if you joined us or watched any of our previous kind of PTP and 2110 webinars, you'll know that we strongly recommend that you build an engineering test bed. And that way you can gain familiarity with the technology, the workflows, the design of the system, kind of without impacting your on-air system. And we'd also recommend that you start upgrading your SDI facility with products, you know, zinc pulse generators like the Leader 4670 that have PTP capabilities, so that when you do start to make that migration, you know, a lot of the products in your facility are already IP capable. And you've got a fair idea. I mean, that's probably a good place to start. Gerard, Ryan, from your perspective as the network that sits in there.
Yeah, Kevin, I would. It's a good starting point. What I would say is most of the, well, a huge number of broadcasters and media generators have already got an IP network with PTP in it. Maybe they've forgotten they've got a Dante network or a Ravenna network, but you know, huge amounts of AS67, huge amounts of audio is already IP based, and of course is already running multicast, is already running across a media capable network, and has already got PTP synchronizing it. So I think I like to kind of think about what and why do we think it's a little bit more interesting in 2110 land, I think is an interesting question. And I guess it's a result of all the benefits that you kind of talked about: scalability, resilience. We kind of moved to a slightly different network model. In the traditional audio model, which works really well, they're basically layer 2 networks for simplicity, for configuration simplicity, and for kind of device discovery simplicity. And that has and the PTP requirements, the timing requirements for audio are just a little bit less. They're less precise than they are for 2110 installations, and that's led to networks that have got decent quality of service configurations, but are really not configured in any special way for PTP, other than delivering multicast well and quality of service for PTP. That it all just works. So when we get to 2110, we've got a higher requirement. Like we're looking for, I don't know, plus or minus 100 nanoseconds is definitely achievable at the endpoint. And once you move to that, you kind of have to build your network a little bit more, with a little bit more thought. And we'll go into that, I guess, as we go through this webinar.
So Steve, for most broadcast facilities, the biggest challenge they've had to face was migrating from standard definition to high definition. And from a reference perspective, that involved moving from black and burst to tri-level sync. Well, actually, some didn't even bother doing that, did they, to be honest? But obviously, they've now got to consider PTP. And that's not to forget NTP as well, you know, which is needed for non-PTP capable devices in the network, you know, to allow coordinated logging, for example.
Kevin, you're absolutely correct. PTP is completely different animal. You know, with black burst or TLS, tri-level sync, we dealt with analog levels, phase, frequency as a reference. Well, PTP is time-based. It relies on packets and timestamps. It's precise down like Gerard was talking about, you know, even below 100 nanoseconds. So we can depend on that as our configuration, and as long as the network performance will, you know, achieve that easily. But the biggest thing is, like with our LT4670 SPG, it's also an NTP server and an NTP client, and works off of a OCXO, which is an oven controlled crystal oscillator. So everything is being synced to that oscillator and keeping that oscillator absolutely perfectly in phase with PTP. Because if you lose something, we always have that to fall back on. And every single device that's inside of that generator is running off that same oscillator. So none of them can ever separate or be out of sync with each other. So it's really nice. But so if GPS is not available, we can use NTP as the lock for date and time, with everything still running off of that 1 ppm crystal oscillator.
I think the other bit also is, you touched on there, the reliability of GPS. You know, there are certain territories where that now can't be taken for granted. And we are seeing people look now to use PTP as a reference. You've dealt with before, isn't it?
Yeah, we have some customers who are looking into using technologies like synchronous Ethernet to deliver a frequency and a phase, and then on top of that, the PTP protocols can be used to deliver that time of day and give you a very accurate non-GPS or non-GNSS based time source. Some of the customers we've already got cesium clocks running locally. They use GPS as a backup, even though that quotes backup is actually the thing that the cesium clock is avoiding you having to use. So it's kind of interesting way around seeing it. Ryan, have you seen anything else?
From what perspective? I apologize, Ryan.
Well, I guess from the perspective of people who are worried about whether GPS or GNSS is going to be available for them all the time.
Yeah, like I see that with trucks often. Like I work with a lot of OB truck vendors, and I think the most concerning part for them is like they won't be able to guarantee that they'll be able to see the skies. You know, they might be distributing video from under a stadium, under an arena, or something like that. And that's actually a question I get asked relatively often, and generally have to point to, you know, some more reference gurus there on like how will we actually be able to distribute, PTP and, regular, blackburst accurately and in time together, without seeing like, without being able to get access to a GPS clock. That comes up, quite frequently for me.
So what happens if somebody turns up with a truck running a different domain to the one you want to run, Ryan? Is there something we can do to fix that?
Yeah, like, we have the capabilities, for example, of like doing, changing the announce messages to like output specific domains. So like if an entire truck is locked to domain, I don't know, 100, another truck pulls up on domain 90, for example, we can lock the two trucks together, for example. I think that's a really
Nice.
slick solution, just by changing the domain that goes between the trucks without having to like change all the devices and all the switches. That would be really challenging to do in a very short amount of time.
I mean, the other piece also we're seeing now is that, broadcast facilities are saying that they sort of want the truck connected to their timing. And, I think we're seeing more and more people ask for that now as they start to lift the hood on 2110 and their deployments. How do I work with, the OB companies that with SDI video, it's quite simple, but suddenly with the world of 2110, there's another layer of complexity to it.
I think that's the feature that that Ryan was just describing. Kind of, I always think of it as like a PTP NAT domain, or natting of the domain number. It isn't that, but it's kind of makes my
It's
head
like
work.
that, Gerard. It's a good description. It's a pretty good description of it.
Yeah, and I mean the problem you described, Kevin, is one we've addressed with a number of customers. Actually, we got a white paper. We could maybe try and link to that in the chat or something, which describes exactly, well, quite a lot of what you're talking about. How do I take one truck, which is designed one way, and attach it to another truck without having to do a load of configuration on the interfaces between the trucks? And there's some techniques like IP unnumbered that enable you to do that. So it doesn't fix everything, and you still need to do some thought, but it could. And the PTP domain, the ability to change the domain number on the fly from the facility, that would need a bit of changing, but that could definitely help quite a lot of this sort of stuff.
So, Steve, I think one of the other bits that frequently now come up to us, we're coming from the world of broadcast, where we expect the most unexpected thing to happen at the most inopportune moment. So therefore, in the world of SDI, these systems were built, with complete backup. Obviously, SMPTE 2022-7 has provided broadcasters with that confidence of redundancy. But it's been quite interesting chatting to kind of some people looking at this, that they don't seem to understand that actually 2022-7 is actually kind of load sharing. This is not red is the primary, blue is the backup. And that brings with it, doesn't it, a whole series of challenges, Steve, when it then comes to basically reference timing on what is technically an air-gapped network.
Yeah, it really does. As you said, Kevin, a lot of people are used to the SDI world where, you had a link, let's say, coming from a studio coming in to a facility, and you had specific primary and backup networks. You were writing 100% on one network. If it failed, you switched over to the other network. And within the world of 2110, running a red and blue network, they're both sending the same exact data at the same time. And we actually are running devices that are in the receivers that are packet pickers, and they're looking at both networks simultaneously to see what is going on in the network, and they're picking whichever device or whichever network sends the packet first, and they're comparing the packets. And if one network sends the packet first, it takes that packet. If the blue network comes up next. So in a properly balanced network, it really should be about a 50% load share across the red and blue network about which packets are actually physically being used by the receiver.
And Gerard and I have discussed this recently, where you've got a red and blue network, but obviously the system only has one grandmaster.
Yeah, and since you're using the timestamps within the headers of the multicast packets, if you have two different grandmasters and they're fractionally out of phase with each other, that could completely change how your -7 works. And you could be completely relying on one side or the other side because of that.
And
Yeah.
and if I can add something to that, like,
Yeah,
we're talking about
please.
2022-7, like from a just a multicast data perspective oftentimes. But,
Mhm.
in working with many customers and like kind of reviewing, going back to what was said earlier about, testing things out in the lab, for example, what I've noticed, and I've had countless conversations with Gerard about this, is like, just because there's a standard for like 2022-7, they'll pick red packets and blue packets. You don't know which one necessarily which. The devices, when they're locking to both possibly red and blue side, I don't think there's anything in the standard that says that they must do a BMCA between their red and blue devices, right, Gerard? Like, there's nothing in the standard, I don't think, that says that. So you might get like different behavior from different devices, right?
Yeah, we absolutely see that, don't we? I mean, and you're right. I mean, there's nothing in 1588 that describes how an ordinary clock deals with having two interfaces. As far as it's concerned, you kind of imagine maybe, I mean, it could do anything, right? It could lock to both. It could make a clock that's based on locking to both. It could lock to the first one it sees. It could lock to the one that's got better BMCA. Yeah, absolutely. I mean, if you think about the way a switch works, it runs BMCA across between those two interfaces, or between multiple interfaces, and it chooses the best clock that it sees, and then the tie break, because it sees it on multiple interfaces, is essentially it's the lowest internal interface ID. It's as kind of basic as that. But yeah, my experience is that many endpoints don't do something like that. And the problem you've got if the endpoints doesn't do something like that is if you have a separate clock in the red to the blue, you don't really know what's going to happen if those two clocks are not perfectly locked together.
Yeah.
Yep.
And it's easy to get, very small, we're dealing with incredibly small amounts of time, and it doesn't take a lot for the two networks to be not absolutely perfectly phased with each other. So, I mean, it's weird things can happen, like you said, Gerard.
Yeah. So, I mean, for us, from an Arista point of view, we roll these networks out all the time, and
Mhm.
a hard recommendation. In fact, if a customer's not doing this, we're asking very awkward questions. A hard recommendation is that all endpoints in the entire network, red or blue, they'll receive the same GMID from both network interfaces.
Yeah.
And maybe you can
And-
explain it, because people say, oh, it's air gap, there is no connection between them. But as you can see on here, the VLAN between the two PTP distributions, they're absolutely critical, aren't they, Ryan and Gerald, for this to work?
Yeah, like those connections between the red and blue PTP distribution switches are absolutely critical here. And while folks do typically say, like, yeah, like you said, like a red and blue should be air gapped, yet hey, they're not actually air gapped. We're writing here that it's a VLAN. It could be a VLAN, or you could just make it a routed interface that has no IP address associated with it. Its only job is only to distribute PTP packets, and that's it. Like, it is a critical connection in this network to establish consistency from a GM perspective across the red and blue networks. But there is, of course, security you can implement to say, like, no traffic can go between the red and blue networks via those distribution switches. You could prevent you could prevent BGP or OSPF peering. You could disable multicast on those interfaces, because although PTP is multicast on a boundary clock, it's not really multicast. Like, we're just outputting it on those PTP enabled interfaces. So there's lots of like security measures we can take to ensure that, yes, they are physically connected, but they're not really going to be logically connected. We're not going to allow peering. We're not going to allow multicast to go over those networks. Gerard, I don't know if you had anything else to add on that.
No, yes. Well, I mean, that was all great. Completely agree with you. I was going to say, actually, we talk about air gapped a lot, and I think we have talked ourselves into believing they have to be quote, perfectly air gapped. Most of the networks I build aren't air gapped at all. What they are is they guarantee you path diversity, i.e., if I've got a red and a blue flow from the same sender, I will not take the same physical path and I will not go through the same switches to deliver that. So that if I lose a path or a switch or a spine, I can lose a red flow, but I won't lose its appropriate blue flow. That's what I mean. That's what we're looking to achieve. If you say they're air gapped, you're kind of guaranteeing that's what you're achieving. You're guaranteeing the path diversity. And I think a lot of people would like to see them air gapped because you can see it as it's a more resilient system if it is less connected to the other system that you're relying on. But a well configured and designed network almost certainly isn't truly air gapped. You've got this PTP connection, and often those spines that we see there will be connected to some form of a out of band management or kind of a control and monitoring management network, and that clearly connects those two networks together. And in most systems, you absolutely have to do that anyway. So probably just needs to be a bit careful about this idea of air gapped not being taken too literally.
Yeah.
And
Yeah, from a
obviously,
2110 data perspective, yeah, it's air gapped, I guess you would say, but not from a complete management perspective.
and what I recommend is, like with the leader products, we can connect to the red and blue networks, and you'll see that one port is locked and the other one is ready. So you could see that, the backup is there, it's running and it's ready should there be a failover. And then if there was a complete dying on one of the grandmaster or if the BMCA switched over at the top there between A to B, you'd see this switch over and port 1 and port 2 indicate that they're now picking it up off of the second one. So, there are tools out there that can give you that confidence right at the end point that PTP is traveling across the whole network, and it's, you've got the clock ID that you're expecting to see at the end point.
Arista's Cloud Vision, for example, can show you the path, the topology of the PTP through your network. It can show you what the GMIDs that are present in your network are, and you can set it up to give you alerts and events should a GMID that you were expecting not be present, or there be multiple GMIDs or funny domains or unexpected transitions from one GMID to another. So yeah, building a monitoring system is, I would say, critical, but it's not tricky. There's other solutions are available, but Cloud Vision does a pretty good job actually.
I think it's important to get, especially with PTP. You can have BMCAs happen at any time, and they might be and obviously they're going to be very specific on when they occur. We want a monitoring system that will tell you exactly when something happens, like down to the millisecond. It's really important, and to see possibly a cascade of events if it happens because of that. Sorry, Gerard, for.
Yeah, and remember that a BMCA event doesn't have to be a massive failure. BMCA event may be a wet tree in front of an antenna, which has made your primary GM sees slightly fewer satellites, and so your secondary is now it is a better clock, and the right thing to do is to fold over to that one, and that's that isn't a failure. That is simply PTP working to give you the best clock it can do in all situations.
It's working as it's designed. Just because there's a
Yeah,
BMCA event where
yeah.
everybody switches GMs, it could be the preferred thing.
Yeah.
And obviously the other bit is on the kind of lead and fabrics products is logging that if a boundary clock happens to, should we say, infiltrate the system, because the way that it's been designed, that suddenly, maybe appears when you don't expect it to in the hierarchy. So, as I said to people, these systems are out there, right. There are a lot of people using this architecture very successfully.
Yes,
So
absolutely.
you
Yes.
don't have
Yeah.
to reinvent the wheel if you're starting from scratch.
There are so many reference architectures out there, so many, different white papers available. I think it's a, agreed upon topology, and it's tried, tested. It works. It's redundant. It delivers time in a resilient fashion.
Integrating hybrid facilities. So we're now going to drop this brand new IP PTP system on top of an existing SDI infrastructure that's got black and burst, tri-level sync, Steve, maybe even SDI as a reference to some devices, and digital audio. That's the real world that most people live in, isn't it?
Yeah, Kevin, it is. Most broadcasters have to adopt a phased approach. They just can't shut the station down and walk 100% over to something else. So they might start with IP islands. And as we mentioned earlier, it's actually really advantageous if they can start with a sandbox where they can build what they want to do and make sure that it works how they think it should, and actually learn the new measurements, learn the new systems, learn all the configurations outside of their working system, and then implement that in an island, and then gradually expand that as we go across things. And the biggest thing here is maintaining absolute sync across your SDI and your IP sides of the house. They've got to agree with each other, because you will be taking signal sources from both sides, and we still need to make sure they are absolutely perfectly synced. So products like the LT4670 can lock to either GNSS or PTP and give you 100% quality lock. We can go down and lock to black, but your black reference from a clock quality is going to be a lot less than what it would be if you were to lock to GNSS or PTP. But all the sources will be referenced to that single oven control oscillator we were talking about before. So in the catastrophic failure, if you lose a reference, the LT4670 goes into what we call stay lock mode, where the oscillator just stays exactly where it is. Every device is running off of that oven controlled crystal. And when sync is restored, it slowly phases back into perfect agreement with that external sync source, so that your whole system doesn't take like a 360 loop to find sync again. And as far as any device working on the end, you'll never see it. And if you look at the diagram that's up there, that top left corner is that oven controlled crystal that we're locking to whatever your sync source is, but every output device is coming off of that crystal controlled oscillator. And we can go through and have absolute perfect sync between everything, whether you're locked to your output or your input sync device, and or having to free run, if you will, off of that oven control crystal. All outputs never see any change.
Excellent. So Gerard and Ryan, as you said, you've had a number of installations and that predate 2110, and for once the broadcast industry is not on the bleeding edge of adopting PTP. Probably the slight difference is now that you've got broadcast equipment manufacturers like Leader coming in with PTP generators.
Sure. Yeah. I mean, PTP's been widely deployed for a long time. I mean, it's what synchronizes power stations. It's what it's what is synchronized. I mean, it's part of what is making sure that the CERN Large Hadron Collider is capturing results at incredible precision. It's telcos are using it to make sure that mobile phone masts are properly synchronized, and the frequency sharing that they're supposed to be doing is being done properly. So it is all over the place. And as you say, it's interesting that, now we've got an interesting mix between, companies like yourselves who are broadcast focused because you're delivering value with black and burst and tri-syncs and changeovers and stuff like that, and the more traditional other PTP vendors. So it's a very interesting market with a ton of great products. I mean, obviously, the ones you typically need a bunch of very clear broadcast capabilities, and who better to get that from but a broadcast organization, right?
Moving on, obviously, we've talked about already that the tools are out there for monitoring PTP, but now for our broadcasters in that hybrid environment, you're going to need tools that allow you to look at your PTP and black and burst and their relationship. And what we've done deliberately is take a tool that any SDI engineer is going to be familiar with, the good old traditional crosshair, Steve, and we've simply ported across. And in this particular example here, we're looking at PTP versus black and burst phase.
Yeah, because Kevin, we need to make sure, like we talked about, it's going to be a phased approach for most people. And your PTP needs to be in time properly with your SDI facility. And you need to have the tools to be able to measure that and manage that. And so that when you switch between sources, everybody's still happy.
Yeah. And then there's other bits that 2110 brings to this. PTP and RTP phase.
Yes.
And this one, we're obviously not going to explain this, but anybody who's seen our presentations before, we explain this by showing an analog waveform, don't we, Steve?
Yeah.
Here we are, 21st century, talking about IP, and we're reverting back to an analog waveform. But the reason being is that there is a vertical phase offset. 2110, the active video -20 does not start at line 0 pixel 0, does it?
No, it doesn't. So PTP starts at line 0 pixel 0. Black starts at line 0 pixel 0. But the timestamp for where does video start needs to be for the active picture raster, needs to match where SDI picture raster starts. And so there is an offset, and you need to maintain that offset correctly so that, like we said, when you're switching, we're where we want to be.
Exactly. And along with the tools that people are familiar with, we also have graphs to show the timing of those over a period. And,
yes.
The leader products can scale anywhere from 2 minutes up to 72 hours, because the one thing we've certainly learned about IP is it doesn't typically drop off a cliff, but boy, you can see trends in it. You can start to see stuff getting slower or getting faster.
And sometimes something will happen, either man-made, quite often, or not, where you may just take a hit at one point in time, and you'd like to figure out what in the world happened. And you have the ability to look back, like you said, over great periods of time when something took a hit in the middle of the night last night, and chase it down.
And the one that I find really useful is basically that first packet time. When did that first packet of active video actually arrive?
Yes. Yeah, because if there is a timing offset, that's the one that's actually going to show where the video actually starts. And that's the critical one that needs to be at the proper point in time when that first pixel of the active video starts, and it is matching the SDI first pixel of the actual active raster.
Because there's plenty of times, Steve, where I've had a phone call saying, well, look, I'm looking at the status and it says that my -20, I've got a stream and there's data on it of 1.09 gig, but I've got no picture.
Yeah. When I've seen those before, almost every time it's because PTP has slid in time because some device either woke up unhappy or something happened to its reference and it's outside of the buffer window that PTP is, starting.
Excellent. Well, I'm conscious of the time here, and I know that we've been getting lots of questions. So, Cindy, are you in a position to jump in now and act as the moderator and start sharing some of those questions? So, for those of you who got your questions in early, that's no guarantee we can answer it, but we'll hand it over to Cindy now.
But we just want to also make sure for everybody, every question that is submitted will be answered. We will not have probably time, and some of them may require more in-depth explanation than we can do on this seminar. So, but everybody's questions will be answered.
So are we ready, gents?
Cindy,
We are ready. We are ready. All right. Could you talk more about situations where you have one grandmaster for PTP ST2110 and AES 67, but their profiles are really different? And how do you synchronize audio data flows between those networks? We've got several questions about audio timing, audio synchronization.
I can have a stab at that. So certainly how I interpret that is to ask about where 2110 like message rate profiles are different from the AES 67 message rate profiles. So there's a couple of things in there. First is that there is a common set of message rates, which is defined by AES 67 R16 2016, which specifies a set of message rates which both 2110 satisfies 2110 and AES 67, which is and a set of those numbers will be announced message per second and 8 delay requests and 8 syncs per second, and that is our recommended set of numbers. But if you have devices that you want to run at a different rate, then one of the benefits of a boundary clock is, in our world, you can specify what rates you want on what port. So if you want to reduce those rates to lower message rates to support an audio device that can't cope with higher rates, that's fine. You can do that, and you can run your 2110 devices at a different rate. We see that quite often.
But Gerard, that would be specific though if we did a boundary clock, yeah? Yeah. So like, and that's one of the recommendations, like why we like boundary clocks so much. If you were running like a transparent clock, that'd be different. But boundary clocks give you that kind of flexibility.
Yeah, I mean, I recommend strong recommendations, boundary clocks at all levels. You get these features, you get security, you get better visibility, you get a ton of cool features which you don't get with transparent clocks, for example.
Several questions about hybrid deployment, and wondered if any of you could talk about hybrid deployment. Do you recommend having a hybrid system? And if so, what criteria is to think about, especially when you're redesigning this hybrid system to transition to fully IP?
Well, I think as we touched on it, having a testbed system, understanding what what are you trying to achieve, scale, then you can start to scale and understand. But then also, loads of people out there have sync pulse generators and that have probably been in the facility for 7, 9, 10, 12 years. They've just run in the background. If you're looking to replace those, look to replace them with a device that has PTP capabilities so that you can then start to put IP islands that are timed to the rest of your system so that you can start to that phased migration, I think is the term. And as you become more and more comfortable with it, you'll eventually get to the point saying, well, actually, why have we been doing what's been holding us back all these years? Why haven't we been doing this? Because this does actually work. It's a lot more efficient, and suddenly now I can share my content. I can bring people in from outside.
I would agree. I think a really strong starting. Well, okay, let's step back slightly. I would say 99 point something percent of installations are hybrid. I mean, they are systems which have got IP in them, and they're systems which have got some stuff which is still SDI. And in that world, you're almost certainly still going to have some black and burst of trisyncs to synchronize that stuff. and you've still got a bunch of audio with word clocks and stuff like that. So I think it's a nice idea to build a pure IP system. It doesn't happen, in my opinion. And so once you're happy, and why would it, right? Because you want to use all the kit that's still got some life in it efficiently and effectively. You don't want to write that all off until you need to. So from a efficiency point of view, you're going to do that. So if you're going to build a hybrid system, the first thing you're going to need is PTP as well as Black and Burst. So I completely agree with Kevin. The first project is to build yourself a timing system that delivers hybrid timing. And that then starts to give you a playground in which you can learn about PTP, learn about multicast, learn about all this new magic stuff, learn about IP if you need to. It gives you a starting place, and it allows you to deliver those timing signals wherever you need, even to the old stuff and to the new stuff.
And I would highly recommend as soon as you can that you make your hybrid timing system your actual master timing system for the whole plant, rather than time the PTP system off of Black and Burst, because the clock class is so much lower, and you will have so much better resiliency and accuracy if you can migrate that sync system as the master sync for the entire facility. I know it's a pain in the butt to migrate a sync system, but the benefits will outweigh anything that it takes to do it, just because it becomes now your system that has one oscillator, one clock, everybody's locked. I've seen facilities that are massive 2110 facilities turn up and say, we're not going to have one SDI cable in there. And before the switch is ever turned on, they've got hundreds of SDI cables running around. Part of it is there's a lot of reference monitors that are only SDI that do not have IP inputs. That's probably one of the biggest places I've seen this. And just there are pieces and parts that you're still going to have that's going to be SDI, like Gerard said. It's not going to happen. On paper, it sounds wonderful. Sounds great, but I've not seen it since 2110 started that a facility's gone up and not had some SDI somewhere in it.
I see a couple people are asking about the Arista paper, and we'll be sure we follow up with you that you've got the right link for it, or if we need to update the link, we'll take care of you. I promise. We got you.
Yep.
Yeah.
Good.
Yeah, we put out the link for where this will be posted. We'll provide all the external links also at the same time.
Yeah, we'll do a follow-up email with the replay. We've got a couple people asking for slides, so we'll get you the replay of this video and any links that we can in the email as well. So you just went through a great system. We looked at a block diagram earlier, and just to ask this question, somebody's saying, hey, is it really possible to find all the different equipment that you need for a full IP system for PCR and MCR? Is that gear really out there? Does it exist?
Yeah, there's literally thousands of broadcasters doing this right now.
Yes.
Biggest names on the planet are doing this right now. Yeah. Short answer, yes.
And
Yes.
the great thing is there's a choice of manufacturers as well now. You know, we've moved on from that sort of a la carte menu of, well, this, and this. Now, you know, we're back to where we were with SDI. You've got a choice. And also there are some new players in there, aren't there, that have never dabbled in the world of SDI video, but with 2110, you know, they're bringing a different mindset and different set of, you know, approach to how we make programs and how we send these signals around.
Yeah.
Yeah, I mean, have a think about what you watch on the telly. Do you watch the Olympics? Do you watch Formula One? Do you watch the World Cup? Do you watch the Euros? Any of that? Do you watch the golf or the tennis? It's all been through 2110 somewhere.
Yeah.
And when they're going through 2110, I think it's pretty safe to say that there's so many different vendors in there you really do have the opportunity to choose best in breed for everything from multi-viewers to switchers to cameras to monitoring to, everything. You don't have to stick with necessarily just one vendor. We really believe in interoperability here.
Yeah. And that's the whole thing about beautiful thing about 2110. It's an interoperability standard. And yes, when we started, interoperability was kind of hit and miss, but we've been in this long enough that interoperability is pretty well there. But again, that's one of the reasons you want to start a sandbox, because if you're going to put a new device in, you want to put it in your sandbox first, test it, make sure it works, make sure it does interoperate with everything else you're going to deal with.
You know, from our perspective, there is nothing more kind of we like to be involved in when the customer says, you know, could we borrow, you know, a leader or a fabric, because we want to put it in our test bed system. We want to see what's going on. We want to start building a set of parameters that we're going to test and are going to become our standard, you know, in our facility. So, you know, everything goes back to that test bed system. Do it and it'll be your best friend. I said it also allows you to roll software versions and stuff like that and try things out.
Couple questions around having multiple facilities. So I've seen a few come through like this, and one of them specifically is if you've got a couple facilities a few miles apart and each one has its own PTP system, is it possible to link the facilities directly via 2110 without the use of a device to resync signals from one building to the other? What are the distance limitations on that? And we have other questions around dealing with multiple facilities and sync signals and reference and 2110 between. Anybody want to comment on that?
Well, I'll jump in a little bit. One of the unique things that you got to remember is fiber still has the same delays, or almost exact same delays as copper cable has. If you timestamp a packet at one facility, you deliver it to another facility, you're going to inherit that delay coming in. 2110 does not get rid of frame syncs. You've still got to be able to align those packets with your current time. And you do have to go through an alignment. You can't just grab that timestamp that's coming in, because it's going to be down several lines and probably horizontally offset from where your existing house is. So,
well, Steve, we've got a very good customer in Italy, and they have studio facilities in Milan and Rome, and they will do programs that use both studios live. And the first thing they do is, before anything goes out, is they take this, they're in Milan, they take the signal from Rome, and it's 500 kilometers, or as the engineers say, it's 161 lines. And they verify that's what they expect to see, because obviously they're going out over a network that they have no control, that's doing the switching between Rome and Milan, but that's what they expect to see. And they fire it up. That's what the camera in that studio, that's the offset. Therefore, that's what we need to manage. And as you said, it doesn't replace frame synchronizers.
I mean, everything you said is spot on, right? I mean, the workflows don't change. The source of time has changed, but the source of time is still giving you an identical set of time in two locations. I kind of interpreted the question about whether I could run one facility off somebody else's PTP, and that's a good question. We get that a lot. So I think there's a long answer. I'll try not to give it. If you've got multiple facilities, do you want to share a single failure point, right? It's not a single failure point, but if one facility loses all of its PTP, do you really want to lose all of the PTP in another facility? So I would typically say to people, if you've got a big enough facility that warrants a facility, have your own PTP system per facility. Doesn't mean you can't monitor them both. You know, a PTP distribution system is not an expensive thing compared to the rest of your facility. The other question comes in, well, can I run my OB truck off a remote link, or can I run a satellite facility? Well, not satellite, not as in the sky satellite, but something far away. And the answer is, what is the network between you and it PTP aware? If it is PTP aware, then theoretically you could, or if it's dark fiber, theoretically you could. If it's not, then you can't, because you'll build up non-PTP related, non-PTP aware switch related problems. But fundamentally, I still come back to, is it worth saving money to not have redundant multiple PTP sets in facilities which are separate facilities fundamentally?
We've got a couple questions about LTC and PTP. I see 3 of them in here. And so one of them is about using cinema style cameras in a broadcast live environment, and looking for a way to work with LTC and PTP. Is that something you want to comment on?
Well, yeah. So when we generate all of the sync signals, one of the sync signals we are generating is LTC that is locked to the rest of all the other signals. So LTC still exists. We still generate it. It will be perfectly lockstep with the rest of the signals. So coming off of that hybrid sync generator, one of the, we've got multiple LTC outputs that each one can be phased or manipulated if you need advanced or delayed LTC. But it is hard locked to the rest of the signals going on in that facility. So it works perfect.
And along those lines, somewhat related, got a question here, just really asking if your equipment switches to the internal oscillator, is it really seamless?
Oh,
It depends on what caused it to switch. If it's if it's a failure of something that's in front of, between the sync source and the receivers, no, they got to detect the loss of that signal before they walk over. But it's fractional seconds. If it's losing GPS, yes, it's seamless, because the clock class changes. It's still perfectly phased. The other generator sees the clock class change, and it tells the other generator, hey, I've got a better clock class than you. You go to passive, I'm going to take over. And it's essentially seamless.
So we are in the process at Leader of probably a week or so away of publishing a white paper that actually talks about how you should commission these PTP systems for different types of failure. We've talked there about GPS, so obviously that's changing the clock class and the best master clock algorithm reacting accordingly. Other methods involve changing priority 1 and priority 2 status on devices that could become the grandmaster. Then there's things like losing the link, power outages. All of those we're going to talk about and demonstrate how you need to consider those, and you need to design your network so that they're not going to be a catastrophic failure. And another one that Steve and I will probably return to with another video or another seminar is talking about reference mismatch. And that is something that really is applicable in hybrid facilities where you have a, say, traditional black and burst failure, but PTP continues to come from the SPG that's a grandmaster, because the best master clock algorithm is not monitoring the health of black and burst, or the other way round. So,
and with PTP having a PTP aware network and having boundary clocks, the boundary clock can walk in and walk right back out as far as being the master source for a fraction of a second, and you never lose PTP. It just keeps right on going.
So as I said, look out for it. We will be sending out a link where you can download this paper. Once I've finished writing it, it's nearly there. But then it has been, hasn't it, Steve, for the last 2 weeks, nearly there.
Yeah. Anything you want to add, Gerard?
I don't think so. No. Yeah, we're always here. If anyone needs any help with anything, please reach out.
Yes.
Happy to help.
Everybody, I think we've hit our time.
We have. Well, obviously, thank you, everybody, for your questions. We will get back to you. I'm looking at them chugging through here, thinking this is going to be a body of work, but it's great that so many of you have joined us, and it's great that you've got such real life questions. This is showing that there is an appetite to move on now.
Yes. And all of us have been doing this for many, many, many years. And we've got a lot of real world experience sitting behind us.
As the workflows are getting more complicated, so are some of the timing requirements as well. So
Yeah.
it's fun. It's fun to review all these best practices and monitoring techniques. It's good. So thank you guys. Thanks everyone for coming.
Thank you for joining us once again. I'm sure we'll be back in the near future because, as I said, PTP is the gift that keeps on giving.
Awesome. Thank you very much.
Brilliant.
Thanks a lot,
Thank you, everybody.
everybody.
Have
Thank
a
you
good day.
all.
Take care, everybody.